Here they are. Good morning, Marianne, Maddie, Jalen. How we doing, guys? Haha, I got some thumbs up and some smiles out there. Good morning, everybody. Let me hear your voices. Good morning.
Good morning, Mr. Ainsworth.
Good morning.
Yeah, I get to hear some voices. Good morning. Good morning. Good to see you guys. How's everybody doing on this fine Friday? It's beautiful weather out there. Anybody have any major plans going on this weekend that you can tell me about before we get started here today? I can tell you that tomorrow, I'm looking forward to tomorrow because I get to see some friends that I haven't seen in a long time, and they're coming over for a barbecue, and I love barbecuing. So Ainsworth is going to barbecue up a storm tomorrow. What are you guys up to? Any cool plans? Anything happening over the weekend?
Today after school, I'm going to be heading to LA to then go to Georgia for the week.
So who's family or friends in Georgia, Kaylee?
Family, but we're going for my mom's birthday.
Nice. You know, I got to say something very, very positive about Georgia. Every time I meet a student that hails from Georgia, I can remember the last, I met a senior, I think a couple years ago, and he was just the most kind gentleman I haven't, that I've met in a long time. And I go, man, his manners were so good. The way he spoke was so good. And I said, where are you from? Because I was thinking Georgia, but I wasn't sure. And then he spoke up to me and he says, yeah, I'm from Georgia. And I go, everybody I meet from Georgia has like killer manners. And I don't know what it is. I've never been there. But everybody I meet from Georgia is like amazing, like in respect to the manners. Do you find that to be the case when you go over there?
This will be like my second time since I was like a child, so I really can't say much, but I believe so, yeah. I feel like everyone, like every single time I do go there, they're like very nice.
Yeah, cool. Well, one of these days I'll get a chance to do that. Let me see. So Bella's going to start a garden. Bella, are you going to like an herb garden or a different type of garden? What are you thinking? You can just turn your mic on and talk to me. I prefer your voice. Oh, I got you. Well, you're going to enjoy that. I actually have an herb garden, believe it or not. I made one a year ago in my back half near the horses out there. And we have tomatoes, cilantro, basil, and a few other herbs and stuff. So you'll enjoy that. Plus, I have a bunch of pots that I make too. And then, so you have fun with that. And then Marianne's going to go visit your grandparents. All right, Marianne. So you're going to enjoy that too. God, everybody's going far away. Well, good. Anything else happening with you guys that you guys want to share out before we get started? Okay, then let's do it. Okay, let's get ready. You're going to need, obviously, your activity 784. So have that out. Have another piece of paper out so we can record some extra work on the side. And if you look on the screen, I put this out on Canvas earlier this morning, the agenda for the day. Today, we're going to complete 784 in class together as a class. And then over the weekend, review over the 4 sections, 781, 782, 783, 784. And there'll be a review that's going to be published tomorrow. I have to produce it today and then be ready by tomorrow. And then there's going to be a comprehensive quiz on Monday. So everybody write that down on your schedule, your calendars. I'm talking about this right here. Read the screen. Get your calendars out. Do a quick little notes so that you stay organized. I've been talking to many seniors on the side one-to-one, and in every discussion, we talk about how it's important of staying organized. Just because we're online doesn't mean you don't need a notebook. It doesn't mean that you don't need a calendar and all that. That's totally incorrect. Okay, I have a notebook, I have a calendar, I have everything, even though I'm teaching online, the same as I usually do. All right, so it's important that you guys just stay up on everything. That's the plan. We're going to be using Desmos right now. So let's get that organized too. So I'm going to split the screen, and you guys are going to need to do this too. So everybody do what I'm doing. So open up Desmos because you're going to be working with me simultaneously. And you're also going to be sharing your screen with the class. So I'm going to ask you guys to do that. So you're going to be working simultaneously with me and interact with me today using Desmos. So you're going to need your activity on the side, Desmos up there on a tab or in your phone. Well, not your phone, because you're going to have to share your screen. So use it on another tab. Everybody log in. So go into a new blank graph and go to the upper left, title at 7A4, so you can save your work. So just do what I'm doing up here, 7A4, give it an appropriate title. And you should be, I keep saying this in all my videos that I incorporate Desmos with. You should have an account. You should title everyone, save all your work. And so that by the end of the chapter, you guys have unbelievable resources at your disposal. And that's if you save your work, and you guys need to be doing that. And not only that, you're going to be submitting your work. So in Canvas, you submit the activity and then you print off your work and then you submit it from there. Ali, I just got your message. Thank you. Let me just read it again here. Okay, well, just can you hear me okay? Where you're at here is because your camera's not on. Are you? Can you hear me okay? All right. Just participate, you know, with your mic and in the chat, and you'll be all good. You guys should have your cameras on. We should be visible. All right. You see me every day. I should be able to see you every day. Hang in there, Maya. I got your message too. Just do your best and interact. Okay. So here we go. We need to get started on the first part here. This is an extension from what I talked about in my prep videos. And so period 4, my last class in MRWC, rocked it, man. It was amazing. We had an amazing session. They really showed that they learned something in activities, and they really did a good job. And I'm hoping the same with you guys, because you usually rock the house too, do really well. So let's work together and really participate well. The better you guys participate and the quicker you guys participate, the more likely we are to finish the entire activity in class, which is my goal. I want to do that. But it depends on you guys too. You have to participate well. It's not just good, you know, you got to have a great instructor, but you got to have a great class. It's a two-way street. Okay. It's, I really believe that. So here we go. We should probably read the directions here. So for each one of the graphs, okay, describe the behavior of the function. Okay, let's underline that. That's referring to Y values. So get a couple colors out. Get a red pen and a blue pen and a pencil. I'm going to color code everything so it's a little bit easier to interpret. And so always have a red pen handy. If you have a second color, I'm going to use red and blue to illustrate the different ideas. That'd probably make it a little bit more easy for you guys to interpret. Okay. And I'm going to be using Desmos when appropriate. And I'll tell you what, and we have to describe what's going on in words and in symbols. And there's not enough room here to write it all down in words. So I'm going to put that off to the side. And if you're like me, grab another piece of paper and get that ready off to the side. And then we'll put the symbolic stuff on the activity itself. All right. So here we go. You guys ready? Who's ready to rock? Put your hands up. Dun, 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 dun. Okay. Oh, you know who I'm missing? Speaking of that, because I know. Oh no, he's right there. Okay. I see. Okay. Let me make this a little bit bigger so you guys can see it. Okay, so here we go. We want to figure out what's happening to the Y values when you approach -2. This is a vertical asymptote at -2. What happens when you approach -2 from the left and then from the right? Okay, this dotted line is called a vertical asymptote. Okay, VA. Okay, VA stands for vertical asymptote in my lesson today. So vertical. It's called asymptote. Crazy word for a very important concept in mathematics. That's how you spell it. Okay, but VA for short, just to make things easy. And we have a vertical asymptote at -2. And if you were going to put this equation in Desmos, you would have to type in x equals -2. Vertical asymptotes are always x equals, some constant, wherever it goes through on the x-axis. So this vertical asymptote at -2 is written as x equals -2 when we put that in Desmos. Now, what happens when you come in from the left? This way first. This is from the left. So I'm going to go red is from the left, and then I'm going to switch colors. Blue is going to be from the right, just to keep color coordinated and make sure that it's easy for you guys to read. So what happens to the y values when x approaches -2 from the left? That's what we want to analyze first. And then we'll analyze from the right here in a minute. So when you go from the left, the function values, this curve it's a two-part curve that you're seeing right now. Okay, they start down here, down low in quadrant 3. And as you approach -2 and you approach this asymptote, the function values go up, up, up. These are little arrows, by the way. Okay, and they increasingly go up. And they get higher and higher and higher, and they go to what's called positive infinity, which simply means that it increases without bound. That's how you say it in words. It increases without bound. So that's what happens when things go to positive infinity. And what I'm going to do is I'm going to write it down in words, and then I'm going to translate it to symbols, because symbols are the compact, short, concise way of writing things in mathematics. So if you're going to write this out in words, here we go. So as x approaches, all right, -2 from the left, okay, comma, okay, so as x approaches, and in mathematics, we use the arrow for approaches. I talked about that in the prep video that you guys watched the other day. Most of you guys watched it yesterday. And then, so as x approaches -2 from the left, y approaches positive infinity, which means it gets infinitely big in the positive sense, okay? It means it gets infinitely big to 1 million, to 2 million, to billion, to a trillion, it keeps getting bigger and bigger and bigger, and there's no end. We say that it increases without bound. That's what we say in mathematics. Now that's a lot to write down every single time. So mathematicians symbolize that, and they write it symbolically. So I'm going to go to the symbols now, because it's a much more compact, concise way of writing things. So the way you write it mathematically is you say, as x approaches, use the arrow. As x approaches -2, and then you put this little minus sign above in the upper right-hand corner, like in the exponent position. This means from the left. So I'll write down the word left. As x approaches -2 from the left, so you use that little negative symbol to represent that. You say y approaches positive infinity. That, my friends, is the same thing as what you see on the far right in words. So on the far right is in words, but as symbols, you use the arrow for approaches, and then you're going to use that little teeny negative symbol to represent from the left. So it's a much easier way to write the same thing as you want to represent in words. Mathematicians do all that all the time, because as you get more complicated in mathematics, as you get into college math, if you had to write everything in words, it would take volumes of paper, okay, volumes, and it would just be too time consuming. Now, when you come in from the right side, here we go. I'm going to switch colors now in blue. When x approaches your target point right here is -2. So when you're coming in from the right side of -2, you got to describe the function behavior. What happens to the y values when x approaches -2 from the left? Okay, so you notice that the function starts low in quadrant 4, and then it starts rising, 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 rising. It keeps on going up, up, up without bound. Okay, we say that it approaches positive infinity when that happens. So it gets increasingly big to positive infinity. So I can say that as x approaches -2 from the right, now the symbol from the right is the plus sign. So I'm going to put a plus sign up here in the exponent position. This is from the right. We say comma, y approaches positive infinity. So the plus sign means from the right, the minus sign means from the left. You guys, does that make sense? Give me a thumbs up or down, please. Does that make sense? The little teeny symbols, plus versus minus, okay? The minus sign means from the left, the plus sign means from the right. Okay. So let's do this. Let's practice here with, graphs B, C, and D. They're all different, okay? And get you guys involved, okay? So what I'm going to do is we're going to go from the left first. I'm going to use red from the left and blue from the right, and we'll have you guys try it and have you guys practice it. Okay, so let's start this one here on part B. This is pi halves. So we have a vertical asymptote at pi halves. Okay, and the function does two different things from the left and from the right. Different things happen. So this is a completely different scenario. So let's take a look at from the left first. So let's approach pi halves from the left. Pi over 2 is called pi halves. So I need a volunteer to share your thinking on here. Tell me what you see when you're coming in from the left side. Again, this is from the left.
From the left side, it approaches, or as x approaches pi half from the left, y approaches negative infinity.
Okay, I agree with that because the function goes down instead of up. So usually what I do is I draw these arrows to make sure that you guys are seeing this correctly here. So when you go in, when x approaches pi halves from the left side, the function goes down to negative infinity. So it goes down to, let's say, negative 1,000 to negative 2,000, negative 3,000, negative 1 million. It just keeps on going down and down and down forever without bound. There's no bound, okay? It doesn't stop. And so we say it goes to negative infinity. Now on the right side, something different happens. When you come in from the right side, so let's switch colors here. Something different happens. What do you guys see? Someone else. Take volunteers first. What do you guys see?
I see it's going up and it's coming from right. Up
Okay,
infinity.
so-
I
okay,
write
so-
it down from you.
Okay, so Shane, say it again, but start off by saying as x approaches pi halves from the right, et cetera, et cetera.
Yeah. As x approaches pi over 2 plus at the top, and then comma y approaches to positive infinity.
And what does positive infinity mean to you?
It keeps going up at an infinite number.
Okay, yeah, it keeps going up without bound. It keeps increasing and increasing and increasing, like 1 million to 1 billion to 1 trillion. It just keeps on going up forever. That's what it means. Okay, well done. Okay, so that's what it means by behavior of the function values. What's going on to the y values when the x values approach some target point, some point on the x-axis. Okay, let's try another one. This next one is completely different. Now, this one does not have an asymptote. This
Mr.
one,
Ainsworth,
yes.
do we have to continue writing everything down in words?
You can if you want. I started that way. I'm not going to write it all down in words, but you can if you want, but just make sure you know what the symbols mean. Okay. And so you do whatever's necessary. If you're really comprehending well and you know what the symbols mean and it's clear to you, then you put it in symbols so you can keep up with me. If you think that you should be translating and it helps you visualize and understand it better, then definitely write it down in the words. Okay.
For sure.
Okay, thank you. All right, part C. This one's different. This does not have an asymptote. This one has a hole. Okay, so right here, there's a hole at negative 1,4. Okay, so let's analyze what happens to the function values as x approaches our target point, which is -1 from the left. Okay, so Marianne, the answer is yes. So what happens to the y values here? This one's different. What do you guys see here? Anybody want to take a shot at this one? What do you guys see in this graph? What do you think the y values are doing as x approaches -1 from the left side? What do you guys see? Not, there's no asymptote. Use the word hole instead. There's a hole at -1, 4. You got to describe the function values, the y values. Not sure what you mean, Tristan, on that one.
X does not equal 1. I
Well,
mean,
yeah,
I know that's what a whole means,
right.
but
You wanna-
like, I'm trying to quantify it into symbols. I don't really know how we would write it yet.
Yeah, let's do this. Let me transition here. So everybody look at my screen. Okay, so this is similar to what you're looking at on your papers. So everybody look at my screen. The whole, hang on, there we go. Can you guys see that okay? Now watch, I'm gonna grab a point and trace along the function. Oops, sorry about that. Okay, watch this. Everybody look at my cursor. Keep your eyes on the cursor. The hole is at -1. Let me change this. You got to see -1. There we go. So I'm going to get closer to -1. Now get your eyes on the second coordinate. Right now, y is 2.9. Well, 2.988. I'm going to get closer to -2. Watch what happens. Now y is 3.001. Now y is 3.11. Y is 3.2. I'm getting closer. Y is 3.5. I'm getting closer. Y is 3.7. I'm getting closer. 3.8. What's y approaching to as I get closer to the hole? Everybody look at Kelly and Marianne. The y values are getting closer and closer to 4 because the hole is at -1, 4. The y values are getting close to 4 from the left. They're not going to get any higher because the hole is at -1, 4. Now, watch this. I'm going to jump on the right-hand side. Now watch this. Look at the top of the screen. The y value is 13. Get your eyes on the y value now. You go down and you get closer to the hole. You're coming in from the right side. Now it's 8.9. Look at the y values now. Y values. It's about 8.6, 8.8, right? Like 7.9 down. It's decreasing. It's decreasing. 6.2. 5.6, it's decreasing, decreasing, decreasing. When you're coming in from the right and you're getting closer and closer to the hole at -1, what are the y values approaching from the right-hand side, everyone? Show me on your hands. What are the y values approaching? Okay, they're getting closer and closer to the y value of 4 because the hole is at 4 units high. It's a y value there. So because of that, let's go back to this now. If you're coming in from the left, so as x approaches -1 from the left side, again, this means the left. the y values are approaching. Look at this. They're getting higher, higher, and higher, and higher, and higher, but they're approaching that y value of 4. It's not going to infinity. When you're approaching -1 from the left, it doesn't increase without bound. It gets closer and closer to 4. And then if you're coming in from the right-hand side, if you're coming into -1 from the right-hand side, so use the plus symbol, this is from the right, the y values are also approaching 4 from the right. So when you have holes in a function and you're getting closer and closer to a hole versus an asymptote, then you're approaching a specific number. Like in this case, you're approaching 4 from either side. And on the right side, it looks like this. You're coming down, 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 down. Look at the arrows here. Look at the graph. You're coming down and you're approaching 4 from the right. If you're going from the left, you're going up, 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 up to 4. And from the right, you're going down, down, down and getting closer and closer to 4 from the right. Just like I showed you here on the Desmos graph. All right, you're approaching, if you're coming in from the right, the y values are decreasing to 4. From the left, they're increasing to 4. Give me a show of understanding. This means full, partial, not good right now. Full, partial, not good. Be honest with me here. Can't see Kyle and Ariana. You guys got to give me some, you guys got to be visible. All right, come on. And if not, you got to ask questions, because the better questions you ask, the better responses I give. Okay. Just keep that in mind. That's
that same exact point.
Say again.
Oh, I put that same formula.
Keep going. I'm listening.
Oh, I thought it was cutting out because it said my internet was unstable.
No,
I
go ahead.
put that same exact formula, and then when I go to 1, 4, it just says -1, 4. It doesn't say undefined.
Well, yeah, because you didn't. This is not the exact function of the function that I put in is a cubic polynomial, which is not undefined anywhere. I just made a function, and I put a hole in there manually, Shane. It's defined everywhere, that function that I have in there, but I just manually put in a hole so I can have a discussion point.
Oh, I see it now.
Okay, it's not a rational function, so it's defined everywhere. This one here, I just needed a graph that kind of looks like the one that you have on your paper there, and I put a hole in there manually. I just made that decision. Okay. So don't misunderstand me in terms of, let's say, rational functions, because this is not a rational function. Okay, part D. What's going on here? Dun, 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 dun. Okay, so let's come in from the left. Now this is I think it says root 5. I can't really read the screen right here. Do you guys see a root 3 or root 5? Which one? It's kind of blurry to me. Root 3, Bella? Okay, or root 3? Okay, so let's call it root 3. So here we go. This is our focal point. So root square root of 3. Here's your vertical asymptote. And at x equals the square root of 3. What happens when you come in from the left? Okay, so as x comes in, approaches root 3 from the left, what happens? And then we'll talk about what happens from the right. You guys tell me. Let's take a volunteer. Share your thinking. What do you guys see from the graph here? What's happening? Go ahead.
When x approaches root 3, the graph goes like -infinity down.
Okay, so say it again, but specify from the left or from the right.
From the left, when x is going to -3, the graph goes to -infinity down.
There you go, Berkeley. Okay, so as you approach root 3 from the left, the function goes down, down, using arrows to represent the direction here, to -infinity. So you're looking at that graph correctly there. So they increasingly go more and more negative. So to negative 1,000, negative 2,000, negative 3,000, negative 4,000. Now, what's happening on the right-hand side? When we come to root 3 or approach root 3 from the right, as you approach root 3 from the right-hand side. So again, the minus symbol means from the left, the plus symbol means from the right. So keep that, make sure you understand that. What's going on here? I'll take a different volunteer. What do you guys see? What's happening on the right-hand side to the function values on this graph?
As x approaches as x approaches root 3 from the right, y goes into negative infinity.
Very good, Marianne. So as you go from the right, as you approach root 3 from the right, the function goes down as well, okay, to negative infinity. So I agree with you. You're seeing it correctly there. So as y or x approaches root 3 from the right, y approaches negative infinity, which simply means it gets more and more negative in the negative sense. Okay, it keeps getting down, going down, down, down without bound. Okay. So let's pause here for a second and try to digest this right here. What do you guys think so far? Give you guys the time to, thank you, Kaylee, Shane. Give you guys a chance to ask questions. Thank you, Mason. Ask questions, try to absorb it, try to understand it. So Bella, did you know that eating, writing, and thinking and doing all of that at the same time is a high level skill? It's like college level. That's right. I used to do that all the time in college. I used to bring things in and my instructors wouldn't mind as long as you were very discreet and quiet about it. But that's college level, girl, college level. All right, here we go. Number 2, this is where you guys are going to get involved with Desmos and share your screens. There's some typos in here we have to fix. But before we fix them, I want to talk about all 4 of these functions. So look at all 4. What do they all have in common? Look at all 4 functions. What do they all have in common?
They have a hole at -1.
Say it again.
They have a hole at -1.
Well, maybe they're undefined at -1, but we have to figure out whether they have a hole or an asymptote. That's part of the deal. What's the domain? The denominator for each one of these is the same. So they all have the same domain. What is it? I want to start there. What is the domain of this function? Or all 4 of them?
X plus 1.
No. That's the denominator. What's the domain? Remember, when we talk domain, we say all reals except if it has restrictions. And as we talked about in prior lessons, rational functions like all 4 of these, they all have restrictions. So you should say all reals except something. That's how you start off with the domain. And yes, you look at the denominator x plus 1, but what is the domain? It's because it's not all reals. It's all, you have to say all reals except something, because it's undefined somewhere. You guys comment on that. Agree or disagree with Marianne? Okay, kind of goes back to what Berkeley said in the very beginning. I mean, these functions are not defined at -1. So the domain, all right, is all reals, all right, except, okay, -1. And you simply put it as x not equal to -1. That's how you write it. Okay, so we have to make a typo correction here. So in number 2, it should be each of the following graphs are undefined at x equals -1. So everybody right here, fix that. At -1, make all of these -1. Fix that, fix that, fix that. Okay, there was a negative sign missed there. They're defined at 1. They're not defined at -1. Okay, so the question is like we have to figure out how to fill out this table showing the values in the neighborhood of -1. So what in the world does this mean in the neighborhood? That means really, really close to -1. We haven't talked about that yet, nor have I talked about that in the prep video. So I have to talk about that right now. And then we have to use a table to explain whether it has a hole or a vertical asymptote. Does it have a hole or an asymptote? Which one? Well, Desmos is going to really tell us that. That's easy. So write Desmos in the margin. Desmos required. And then we have to describe symbolically the behavior of the function. That's what we just did a minute ago. And then we're going to use Desmos, which is our graphing utility, to figure everything out. Okay, so what we're going to do is I'm going to model the first one, and then I'm going to have you guys help me with the next 3. All right, this is where we all use Desmos. So I'm going to start with a new blank graph just so that I start with you guys. So you titled this, hopefully you're here. Let's put in the first function. When you type in rational functions, you have to put parentheses around the numerator. So here we go. This is where you guys get involved. So y is equal to x minus 1. Work simultaneously with me, guys, because I'm going to ask you guys to share your screens here in a few minutes. All right, and divide that by x plus 1. Let's type it in. I'm going to show you guys how to make a table of values for your function. In Desmos, it's easy. You can do this in the Tidy4 as well, but you can't share your screen on the Tidy4, so that will be kind of difficult. Okay, so first of all, before we make this a table of values, just look at the function here. Just look at it. Here it is. Does this have a hole or asymptote at -1? Just looking at the screen here. Go to the chat, hole or asymptote. Come on, everybody start thinking. Okay, I agree with that. Write down the equation. What is the equation of it? Because we need to enter it in Desmos. Alexis, stay focused here, please. No, not the function. I don't want the function. We already got that in. What's the equation of the asymptote? Keep trying. Keep trying. Come on, guys. These are all, like, you need to know all this stuff here. Okay. Vertical lines are always x equals a constant. So it's x equals -1. Go into Desmos right now. Let's type that in. If you type in y equals -1, which is a very common misconception, watch what happens. Okay. And that function, or that horizontal line at -1 is not the correct asymptote. Our asymptote is vertical, not horizontal, because this function does not approach that blue line. So that's clearly wrong. So what's cool about Desmos is that it tells you whether you're right or wrong just by looking. That looks more appropriate. The function on the left approaches it asymptotically going up. Asymptotically means that it gets infinitely close going up. If you click on the right-hand side, which you should be doing right now with me, you should be doing this simultaneously. It approaches asymptotically from the right-hand side too. So that's the correct asymptote. So we should probably write that down. Let me see. Let's go to our lesson. So it doesn't have a hole. It has an asymptote at x equals -1. So I just showed you guys how to see it, how to enter it on Desmos, and to see if you're correct or not. Okay, step 1. Step 2, we got to fill out the table. Now, before we do that in Desmos, we need to figure out what in the world does it mean, fill in the table, showing the function values in a neighborhood, keyword neighborhood of -1. Because we want to figure out how do you get really close from the left? What values do you pick? So let's pause here and let's just work on this for a second. So everybody with me. So from the left. Okay, so we need to pick values to the left side of -1. Here's where your number sense comes in. I need a decimal to the left side of -1, between -1 and -2. Like on the number line, I'll just draw a number line. Here's -1. I'm coming in from the left-hand side. I need a decimal that's close to -1 on the left. No, that's Marianne, that's way beyond -2. I want something really close to -1. That's on the right side. -0.5 is on the right. I want a 1 on the left, but it's close to -1. Okay, that's better. -1 point. Get closer. Give me something closer than -1.5. There we go. Now we're talking. Okay, so negative, let's put this in the table. So -1.1. Now I need to get really close to -1. We're approaching -1 from the left, and I need to get really close. So this is closer, -1.01. So -1 1/10, -1 and 1 100th. Ah, very good, Alexis. That's even closer. Get closer. I need one more that's even closer than what she said. Get closer, guys. There we go. Now you're starting to get it. Now we're getting closer. This is -1 and 1 1,000ths. Excuse me, 1 and 10,000ths. Okay. And again, Seth, that's on the other side. Okay. We're talking about -1, so be careful there. Now that's from the left. Let's come in from the right. So I'm going to switch colors. Let's go from the right-hand side. This way, from the right. See, there's a lot more to this lesson than you think. And so it's okay. Don't worry about it. Well, just work with me, Seth, because we're going to put the same function values in for all 4 graphs. So if you worked ahead of me, then just modify your values, because we're going to be corresponding with the same values here in a minute. I need a value, a decimal to the right, close to -1, but on the right-hand side. You guys don't just put a number in the chat or speak out loud, one of the two, and don't worry about making mistakes, because I don't care about mistakes. I just care about us learning what works and what not. You learn more from your mistakes than anything else anyways. Okay, so that's really close to 0, Marianne. Get closer to -1. No, this is good discussion. This is important. Okay, so keep going. That's on the right side of 0. It's got to be negative. Shane, what Shane put up there is close to -1. And then what the point -1 1/10 or -0.1, that's closer to 0. So let's start off with this right here, -0.9. Okay, that's pretty close to -1. -9/10 is pretty close to -1. Now, what's closer than that? What's closer than -0.9? There we go. Now we're starting to get the hang of it. So -0.99. Now what's closer? Let's get closer to that. -99/100ths. Get closer. There we go, Kaylee. -999,000ths. -0.999. Okay, I need one more number that's even closer to -1 than that. Bella, good. Okay, so here we go. Now we got our values. Now we're going to use all of these values for all 4 functions, but we're going to be working on them one at a time, okay? So let's go to Desmos now. Okay, and I'm going to increase this right here. We need to put these in. So here's how you put a table in. Listen closely on this. Notice how I just dragged my function down. You can drag your functions up and down and change the position easily in Desmos. Okay, listen closely here. To change your function to a table, you're going to be using the gear. Okay, this gear icon at the top, some people call it the cog, C-O-G, because the gears inside of a clock, the old-fashioned clocks are called gears or cogs, C-O-G. And the gear wheel allows you to do 2 things. It allows you to convert your function to a table and allows you to duplicate it. Okay, so first I want you to duplicate it. notice that a second one appears. So I want you to, thank you. I know, Destiny, I know you're having issues with that. Do the best you can. And I will post a recording on today if you missed anything. Also, if you need to stay after class or go to intervention, I will work with you individually since you've been having technical issues here. So hang in there. Okay. On the second one, everybody, I want you to click on convert to table and notice the table appears. Okay, so above it on the second row, we have the function. Underneath it, we have the table for the function. This is where you put the function values in. I mean, excuse me, your X values in. Okay, so this always defaults here. It always gives you the same X values, but we need to change them to what you see on the left side of the screen. So that's where your keyboard comes in, or you can type them in on the digital keyboard, doesn't really matter. Okay, so you go negative 1.1 and then hit enter. It goes down to the next one. Negative 1.01 and then enter, then negative 1.001. Just start typing them in, guys, and type all four points in. Okay, so notice that we now see the Y values in the second column. The first Y value is 21, and then the second one's 201. Third one is 2001. The fourth one, 20,001. So they're getting bigger and bigger and bigger and bigger as you get closer to -1. Okay, hang in there, Kennedy. Hang in there. All right, the weekend's right around the corner. All right, now what's happening on the right side? So let's get some values in there. So let's type these in. So negative 0.9999. And then enter, just type them in, negative 0.999.
Oh.
Enter negative 0.99 and just put them all in.
What button did you use to get the chart? Or the
Okay, yeah. So the gear button at the top, you see where my cursor is at the top on the gear? You click on that and then you can duplicate it or you can convert the table. And I said to everybody, duplicate it first. And then on the second one, convert the second one to a table so you see both the function and the graph.
Okay, thank you.
Yeah, you're welcome. All right, so we have our values in. Now what's happening here? So check this out, at -9/10, we have the Y value is -19. And then as you get closer to -1 coming on the right side, it goes to -199 and then -1,999. And to almost, -20,000. It's -19,999. So they're getting more and more negative on coming in from the right. Well, you guys can simply write those values down. I'm going to screenshot it and just import it in here so we can talk about it. Okay, so let me do that here. Okay, so here we go. These are the values that I came up with here. So according to the table, as X here approaches -1 right here, the Y values, these are Y values now, they're getting bigger and bigger and bigger, all right? And they're approaching, well, they're increasing without bounds, so they're approaching positive infinity. So when you write that symbolically, you say as X approaches -1 from the left, Y approaches positive infinity, because they're getting infinitely big, guys. They're getting huge. And then from the other side, from the right side, the Y values, these are Y values here, they're getting more and more negative, from -19 to -199, all the way to -19,999. So we say that as X approaches -1 from the right side, Y is approaching negative infinity. How are we doing so far on that? Do you understand what I'm doing? Let's pause here because we have the graph on the right, we have the function values, and then we have the analysis on the left. let's pause here and ask questions. Because we're using Desmos as our graphing utility tool to evaluate the table, to get the table values, the Y values easily. We can see the function on the right, the graph of the right, and then we can see the analysis on the left. This is the time where you guys reflect and ask questions if needed.
When we put the numbers on the table, will we always do the numbers that are the closest to 0?
Hayes, I'm sorry.
You want to get, hang on, Nathan. Berkeley, you want to go pick values that get closer to -1 because -1 is where the function is undefined.
Yeah, that's what I meant. I accidentally said 0.
Yeah, so we're going to use these same values in all 4 functions because they're all defined at -1. I'm talking about the X values, Berkeley. Aiden, what was your question, buddy?
Is anyone else like randomly getting logged out of the meeting? Like for some reason it's like shut off twice for me now.
I know it happened to Destiny.
Is it just a connection issue?
Yeah, I guess so. I'm not sure. Sometimes it happens. Right now, it seems like it only happened to Destiny once and then in you. So probably just a connection issue. Oh, and it happened to Ali too. So 3 people. You guys just hang in there. I know. This is the tough part about learning online because it's not perfect. Like I said, I'm going to post the class session video up, and I will also meet you in intervention if you need to today, and I'll fill in the gaps and work with you guys one-to-one if you need extra help. Okay, you guys just hang in there. Ali, are you following me here okay on your end? Okay, Destiny, how are you doing? Now that you're back with me here. Okay. All right, let's have you guys try one. Okay, and this is where I'm going to ask you guys to share your screen. So work simultaneously with me here. Let's go to part B. Now, when you do this, put in Desmos, what you first want to do is deselect and turn off your colors, turn off your graphs. Okay, so deselect that, hit save button. So save your work after each example. I've had students have their computers crash and they never save and then they lose all their work. So hit save button all the time. Okay, go down to the next row in Desmos and enter the function in, and remember to put parentheses around your numerator. Okay, so here we go. Y is equal to quantity x squared. Just type it in, guys. +1 and then divided by x + 1. That's why I love Desmos, is because once you do this a few times, get used to it. I mean, it's way easier to use than the TI-84. I used to instruct off the TI-84, and kids back in the day when I did that had so many more problems learning the lesson with the TI-84 compared to Desmos. I mean, it's just way easier. But if you want to use the 84, you can. Totally up to you. Okay, now you have to, once you get the function in, you have to get your table in. So again, hit the gear icon. I want you to duplicate it, and then on the second one, hit the table and convert it to table. So you see what you're seeing here on my screen. And again, the values are the same as the previous lesson. So you want to start in again with the same values, -1.1, -1.01. Use the same X values. So go ahead and get started there. Let me know when you're ready. And we will analyze this one here. So these are going to be the same for all four graphs. Okay, and let me know when you're ready. I would like someone to share their screen, and I'm going to take a look at the Y values and I'm going to screenshot your screen and just bring in your values in here so we can discuss it and go to the analysis part, which is the important part. Desmos does the work for you. It evaluates the table for you as long as you put your X values in there. And then just let me know when you're ready, and then I'll bring your values in and we'll talk about it. I need a volunteer to share their screen here so I can just steal your values. Okay, Marianne, go ahead and, well, hang on. I have to change the settings here. Let me see if I got to make it so that you guys can share too as well. So let me do that. Okay, Marianne, go ahead and steal the screen. Everybody take a look at her values and let's see if she's got the X values in there. That looks good. The Y on both sides. Yeah, okay. Look at that. Okay, so let me steal those values there, if you don't mind. Okay, thank you, Marianne. Let me bring those into the lesson here. And I'll share with you guys what she shared with me. These are her values. Okay, so let me enlarge this a little bit here. Thanks, Marianne. Okay, so let's take a look at what's going on here, and you guys can give me some input here. So this is what she came up with. So let's talk about what happens as X approaches -1 from the left-hand side. So as X approaches -1 from the left, tell me what you see, Marianne. What do you see? What's going on from the left-hand side?
From the left, I see as X approaches -1, Y approaches positive infinity, I think.
Look at the from -22 to -202 to -2002.
Oh, negative infinity?
Yeah, to a negative infinity. These are getting really big negative numbers. So Y is approaching negative infinity. And you can see that on the graph. Let's go to the graph real quick. Check this out, Marianne. When you're, let me put the function or the vertical asymptote in here. Let me turn that one on. So there's the vertical asymptote. Everybody look at my screen. When you're coming in from the left-hand side, the function's going down and not up. Marianne, do you see that? So again, look at the cursor here. It goes up, but then it goes back down. And so as you get closer to -1, the function's going way down towards negative infinity. And that's exactly what's happening in the table as well. Your table, I haven't done it yet on my table, but in your table, it goes from -22 to -202 to -2002 to -20,002. So it's going towards negative infinity here. Does that make sense? You guys, everybody, does that make sense to the class here? Give me some feedback. Because we're learning, okay? And again, it takes a lot of practice here to get the concepts down. This is not easy stuff. Now, if you're coming on the right-hand side, something different happens. So if you come in to approach -1 from the right, look at these Y values in her table. It starts off at -18, and then 198, then 1,998, and then 19,998. So who's got this one here? Who can describe this in words? Come on, guys, volunteer. Participate. Just turn your mic on and go.
You can, oh,
You can go.
all right. So for the next part, I put Y goes to positive infinity.
Berkeley, what do you think?
I agree.
Okay. All right. Yeah, they're getting bigger and bigger and bigger, and they're going towards positive infinity. Okay. Now, look at the graph here, guys. Does this have a, we have to determine this. Do we have a hole or do we have an asymptote in this function? I'm not looking at the chat right now. My chat disappeared.
Asymptote.
Just talk to me here.
Asymptote.
Okay. So no hole, it's got an asymptote. We actually just talked about that. So it's got an asymptote at x equals -1 again, because it's pretty obvious by looking at the graph. Okay. Those are the first two. Now this next one's unique. Okay, this one's different. This one, I like this one. Let's talk about this one. Again, gotta be able to see this here. What happened? Okay, so this one's unique. So we're gonna deselect, turn off your colors here, all your graphs, and then we have to enter this function in. And we're using the same values. Okay, so -1.1, -1.01, -1.001, -1.0001. Okay, same values here. That isn't, that's consistent throughout the entire activity, which is kind of nice. Okay, let's enter this in Desmos first, because it could show us the graph and a lot of information, which is kind of nice. Okay, remember to put parentheses around your numerator, okay, when you do this. So y is equal to x cubed. Now, when you enter an x cubed, you got to use the a to the power of b button. That's your exponent button in Desmos. And then you type in 3. And then to get out of the exponent, you hit the right arrow key before you hit the plus sign, before you add your x squared. Okay, and then divide that by your x plus 1. And you're going to be surprised on what you see. Look at this. What do you call that graph? You guys studied in an Algebra 1 and an Algebra 2. What do you call the name of that graph?
A parabola.
That's right. And what degree is a parabolic or parabola function? You guys remember? It's a parabola, that's true. It's a second degree function. But why is this a parabola? Does anybody know why? Let's stop right now and figure that out. Why is this a parabola?
Is it because there's exponents in the top part?
Keep going with that.
Like, I feel like if you solve the equation, something can cancel something out, and then it can like make an equation that has like a parabola. Like, I forgot what the equation looks like when you graph them, but I know there's like an exponent part with it.
Well, what you said, part of what you just said was like on the right track. You said that something cancels out and gives you a parabola. Can you guys take off on that? What should we do with this function to see why it's a parabola?
Oh, I figured it out. So you take x by the power of 3 plus x by the power of 2, and then you factor that out by x by the power of 2, so then it becomes x by the power of 2 with parentheses x plus 1.
So what Shane is saying is he's saying factor out an x squared and rewrite the function.
Yeah, and then those x plus 1s cancel out.
Giving you
then
what?
X squared, which equals the same thing.
That's right. And guess what? That's called a parabola. That's your famous parabolic parent function that you learned in Algebra 1. Very good. That was excellent. That's why you see a parabola on the screen, you guys, because this is factorable, and you factor out a x squared, and then there's a common factor that cancels out. Does anybody remember what I called that in the prep video? This is important to the lesson here today. What do you call that? It's 2 words.
Is it a removable discontinuity?
Discontinuity, very good. Very good. A removable discontinuity. Let's write that down. So this is in, okay, so let's write down there is a removable discontinuity at x equals -1 because the x plus 1s cancel out. When you can remove it and simplify your function by canceling out a factor, you essentially remove the discontinuity to get a simplified function, which in this case is x squared, which looks like a parabola. And whenever you do that, you don't have an asymptote. What do you have? This, I also talked about this in the prep video. If you remove the discontinuity and you end up with this, we don't have a, well, I don't want to give it away. What do we have? Keep trying, keep trying. This parabola does not have an asymptote, but it does have a
Hole.
That's right. It has a hole. So it doesn't have an asymptote. It has a hole at x equals -1. So it's -1 comma something. How do you find the y coordinate of the hole? I talked about this too in the lesson. The function simplifies to x squared. So how do you find the y coordinate when you know the hole is located at -1?
Would you plug in -1 into the new equation we have, so into the x squared?
And then what is f of, whoa, what, I gotta change colors. What, very good, Kaylee. If you substitute that in and into the x squared function, you said the new function, which is your x squared function, you got to take -1 and square it. And what do you get, people?
1.
I know, that's a really hard one. Okay, and you get 1. So the hole is at -1 comma 1. So let me show you in Desmos how to put the hole in. It's kind of cool. You could do it. I learned how to do it the other day. I was wondering how to do it, and so I researched it, and this is what I found. So everybody type in and do this with me on Desmos. Type in -1 comma 1. Okay, that's how you start it. You type in the hole, believe it or not. So type in -1, 1. And then what I want you to do with your cursor, you can watch me on the screen. I'm going to put my cursor on the left side of the point where that dot is, the color, and hold the cursor down. Put your mouse and click on it. Oh, right there. Click on it and leave your finger on there, and this menu appears. You could change the color if you want, which doesn't really matter, but you want to change it from a solid point to a open point, which is a hole. And look at Desmos. Now the hole appeared. Okay, so let me explain that one more time. So where'd it go? Hang on, let me get my graph back here. There we go. So look at the hole, and then not only that, what's cool is that you can label it. So turn on the label and then type hole. Look at this, and the word hole comes up, and you can see that the hole is located at -1, 1. Okay, and if you try to put your cursor on there at -1, it should say undefined. It's kind of hard to do that though. There we go. See, look at the screen, -1 comma undefined, because you can't divide by 0. Okay, the original function is a rational function, and the rational function is not defined at 0 because you can't divide by 0. So what's cool about Desmos is that if there is a hole, then you could represent it by simply typing it in and then changing it from a closed point to an open point by holding your cursor on the color part of it. This little menu pops up and you can change it to open, which is kind of nice. And then you can screenshot it, bring it in from there. So I don't know. I thought that was pretty cool. So there we go. And then now we need a table. So here we go. Let's go up to the gear icon. Everybody click on the gear. I want you to duplicate it. And then on the second one, make it a table. Now I need everybody to put the values in, and I'm going to ask you guys to share your screen. One of you guys to share your screen here in a minute after you do that. So go start typing in the X values and let me know when you're ready. And again, make sure you hit the save button on Desmos frequently to make sure you save all your work. You have to enter in all the new X values though that are on the left side of the screen. We want to see what happens to the function values, excuse me, when you approach -1 from the left, and then when you approach -1 from the right. Berkeley, go ahead and share. And let me see your function values. Is it letting you share?
It's like asking me for something in my settings. Here, let me.
Okay, hang on. Maybe it's. No, you go ahead and click on the share button.
I don't think I can because it's it's not Zoom. It's like my settings on my computer.
Okay,
and
no worries. Let me. Can anybody else help out?
I don't think you have two screens can be shared at once.
Oh, I did it last period. Let me stop sharing. Now try it, Berkeley.
Yeah, it's not Zoom. It's like my computer. Like Apple is asking me to
Okay, no
change
worries.
settings.
Can anybody help out and share? Go ahead, Kennedy.
Okay. Let's see. Wait, it's not that one. Which one are we on? We're on.
Yeah, right there. There you go. Cool. Okay, so let me grab those. So keep it there. Awesome. Thank you. All right. Let me bring in her values here and let's talk about her values. Cool. Thank you. Let me paste these in here. All right, here we go. Okay, dokie here. So what happens when we approach -1 on the left-hand side, the Y values, oops, let me switch to red here. The Y values, oh, give me a second here, guys. A little technical difficulty. Okay, here we go. So the Y values start at 1.2, then 1.02, 1.002, 1.00002. Okay, they're getting closer and closer to what value, you guys? Show me on your hands. What value are the Y values getting closer and closer to here? I'm looking at the table. One more time, at the top of the table, it starts off at 1.2, and then 1.02, and then 1.002, and then 1.00002. They're getting closer to 1. Okay, they're approaching 1. So we say in symbolically here, so as X approaches -1 from the left-hand side, Y approaches 1. Because we don't have an asymptote, it's impossible to go to infinity or a negative infinity here. It's impossible. We approach the whole, not an asymptote. And then on the right-hand side, it's similar. So when we approach from the right side, the Y values start at 0.8, then go 0.98, and then 0.998, and then 0.9998. They get closer and closer to 1 from the right. So as you approach -1 from the right-hand side, use that plus symbol, y approaches 1, because no matter whether you approach the whole from the left or from the right, the y values are approaching 1. More importantly, does that make sense? Give me some physical feedback on the screen, please. Does that make sense? If not, let's pause and let's talk about it, because I can go to Desmos here and trace the graph and do all sorts of things to help you understand better. Okay. Very good, Destiny. Okay, so let's deselect those. Last one. Let's finish strong here. We can do this. So deselect the, just turn off your colors. Turn off the previous graph by deselecting them. Save, hit save frequently here. Go to your next line in Desmos and let's finish together. Okay, so we have, remember to put parentheses around your numerator up there when you enter your function in. So y equals parentheses quantity x squared plus 2x and then plus 3 divided by the x plus 1. Now, what's cool about Desmos too is that it automatically gives you the graph. And so you can pretty much see immediately whether it has a hole or an asymptote. So you guys tell me, does it have a hole or an asymptote?
Asymptote.
Where?
It is on -1.
Yeah, or at x equals -1. So we should probably type that in too as well so we can see it. So underneath it, let's type in x equals -1 so we can see the asymptote. See, look at that, boom. In green is your vertical asymptote. Okay, so we don't have a hole in this one. We have an asymptote at x equals -1. All right, we're going to use the same function values, excuse me, same x values. So just repeat those every time. That stays consistent through the activity, which is kind of nice. So we're going to see what happens when you come in from the left, and then we're going to see what happens when you come in from the right. Okay, so when you're ready, you're going to go up to that gear icon, and you're going to duplicate your function, and then on the second one, you're going to convert it to a table so you can put in your values. So go ahead and work on that, and then I'll take a volunteer to share their table, and then so I can analyze the last function with you guys. So yeah, Shane, those X values, you could use those too if you want. Those are fine. That's cool. As long as you pick values that are really, really close to -1. Well, you got to make all those negative. I'm sorry. Make them all negative, and then you'll be really close to -1. Just put negative signs in front of all those X values in your table. I need a volunteer here to share your screen, and just so I can steal your table pretty much, because I want to talk about the Y values here. I want to finish the activity with you guys. Anybody ready to share?
I'll just do mine again.
Go for it. Let's do it. Okay, very good. So let me steal those values there. Thanks, Kennedy. Okay. So let's bring her values in. Okay. So what in the world is going on here? Let's talk about from the left side first. Who's got this part? Just turn on your mic and talk to me here. What's happening from the left? Come on, talk to me, guys. Let's finish strong here.
As x approaches -1 from the left, y approaches negative infinity.
That's right. Okay, thank you, Kaylee. And then who's got the from the right?
As
Someone
y
else.
approaches -1. Oh, sorry.
No.
As
Keep
y
going.
as y approaches -1 from the right, it approaches positive infinity.
That's right, because they're getting really, really big from 20 to 200 to 2,000 to 20,000. Y is getting exceptionally big. Okay. So as x approaches -1 from the right, y approaches positive infinity. And that's what's happening on the graph too, when you take a look at it. Now, number 3, last question. This is the main like summary question that you should have learned something big and important from the activity. How can you determine without doing any table calculations, without using Desmos, okay? So I'm going to take away Desmos right now. How can you determine without using a calculator, without using Desmos, whether you have whether the rational function will have a vertical asymptote versus a hole? Do you guys agree or disagree with what Bella said? Everybody read that. Maya does, Kaylee does, Alexis does. Kenny, okay. So everybody write that down at the bottom. That's the answer to number 3. If there's a removable discontinuity, there is a hole, like an example in part C, okay? So, and if you can't factor it and you cannot remove it, you have an asymptote. So you were right on, okay? Well done. Okay, that is the key. That's the answer to number 3. All right. Holy cow, we accomplished our goal today. I was hoping that we'd finish, finish the entire activity together as a group, and we did. Well done. And then I think one of the main reasons why is because you guys were volunteering and sharing all your ideas very quickly throughout the class, and so that's awesome, and that's a sign of a good class. Very productive in that way. All right, so over the weekend, let me put up the agenda that I was talking about. Here's the weekend agenda here. We completed 7A4, so you can scan that and also put your Desmos work in there too, to show me that you use Desmos. All you do is, do you guys want me to show you how you do that on Desmos? Because I can do that real quick. Do you know how to print to a PDF on Desmos? So paperless, I'm talking going paperless here. Does anybody need me to show you that quickly? Okay, you guys are good? All right, so scan your one page, your activity 7A4 with your Desmos. Okay, just submit that. You'll so I can grade it over the weekend and get that in. And then over the weekend, it'll probably be ready tomorrow sometime. I'm going to produce a review with a video attached over the 4 sections, okay? 7A1, 7A2, 7A3, 7A4. And then the reason why I'm doing that is because on Monday, and write this down on your calendar, get your calendars out right now. You're gonna have a comprehensive quiz on Monday. The one you took last Monday that I've already graded and gave you feedback on, which the class did really well, which is nice to see. That was only over section 7A3, Okay, this is comprehensive. This covers the 4 sections. So you're going to need to review everything you've learned over the last 2 weeks on section 7A, 1, 2, 3, and 4, which is today. And so I'm going to help you produce a video for that to help you guys kind of put it all together and review. And that way you'll be prepared for your quiz on Monday, and I'll give you all Monday to do it. It'll be due by midnight, so you'll have the entire day, and you can take as much time as you need on Monday, of course. Any questions or needs before I let you guys go? I thought you did exceptionally well today, you guys. I'm proud of everybody for being here, for doing such a great job. Everybody do this right here. Good job. Dun, dun, dun. Okay, I'm proud of you guys. And you guys have a great weekend. All right, include some friends time, some family time, rest time. It's not all about studying, okay? So you got to relax. So you guys have a great weekend, and I'll see you guys next week, okay? You guys take care.
Bye.
Bye-bye, guys. Great job today.
My cat really likes your class. Like for like the last like 30 minutes, he was just sitting on my desk, just like up close to the screen, just watching you. Like,
He's a mathematics cat.
Yeah, he is. He's so
He's a math cat. Maybe we should come up with a cool math nickname or something.
Yeah.
What's his name?
August or Augie.
August? Augie the math cat. I don't know, get creative, Berkeley, and let me know what you come up with over the weekend.
Okay, I will. Bye, Mr. Ainsworth.
All right, see ya. Girls, how can I help you?
Oh, you wanted to know how we did on the game, so I just stayed.
Oh yeah, tell me.
Well, I got my number 3 school, so I got to start, which was cool. And then we lost though. School was the top 15 in like the state or thing. So.
Well, it's okay. At least you're on the team. You're having fun. You know, in sports, sometimes you lose and sometimes you win. You know, the important thing is you get back off your feet, have a great attitude, you know, reflect on what happened and then improve every day and you'll win. Okay, it will come. So just have fun at it, enjoy it.
Yeah, because we're Division 1. We're like 40 right now.
It's all right.
So that's cool.
Yeah. Well, Vanessa, thank you very much for telling me. Good job.
Okay, bye.
All right, I'll see you soon. Destiny, how can I help you? How you doing?
I'm good. How are you?
I'm doing pretty well. I'm glad you made it to. You had some tech issues or something?
Yeah, it cut out like twice and I had missed the first beginning of class, but I got most of the ending of it.
Do you want me to go back and go through anything?
Sure. Can you go back? It was to the top. It was mostly A through D. That's what I missed.
Right. So let me just clear the screen so we can start over, huh?
Okay.
So let's just do this. Okay. So on the first one right here, what we want to do is describe the behavior of the function values, which are the Y values around the indicated value in words and symbols. So here on this one, we want to figure out what happens as we come in from the left of -2, what happens to the function as it approaches this value of -2 at this asymptote. And so what we were saying is that when you come in on from the left, this is the left side, okay, of -2, the function goes up, okay? It goes up, up, up. As you get closer to the asymptote, the function goes up, 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 and it increases without bound. It gets higher and higher and higher, and those Y values keep increasing, increasing, increasing. And guess what they approach? What do we call that when they increase without bound?
Like the window frame?
Not the window frame. What do you call it when numbers keep on getting bigger and bigger and bigger and bigger and they go towards
I like the infinity, infinite.
Yeah, there you go. They go towards positive infinity in this case because you're going up in the positive sense versus down in the negative sense. So symbolically, we say as x approaches -1, and then we put this little symbol, this negative symbol up there, meaning from the left. Do you remember me talking about that in the prep video?
Yes.
So that means from the left. This little symbol right here means from the left. When you're coming in from the left side of a -2, the y values keep increasing and they get bigger and bigger and bigger, and they get infinitely big. So we say that they go to positive infinity. Does that make sense?
Yes.
And then if you're coming on from the other side, as x approaches -2 from the right side, so we say as x approaches -2 from the right, so we use this plus sign, this little plus sign right here, that means from the right. So from the right, we have to come up with symbols, different symbols, one from the left and one from the right. So we use the negative sign for the one from the left. We use the plus sign for the meaning from the right. Does that make sense to you?
Yes.
Okay. And then the y values, what do the y values do? Well, if you look at the function, I'm drawing arrows here so to train your eyes to see it the right way. It keeps going up and up and up and up forever towards positive infinity again. So on the right-hand side, it's doing the same thing. The y values are getting infinitely big, so they go to positive infinity.
Okay.
Does that make sense? Okay.
Yes.
Now it changes depending on the graph. So let's just do one more, and then I have to transition here to another class, and I have to do something in between classes. So let's do part C, because part C is totally different than part A.
Okay.
Okay. And then of course I'll put the class session video on Canvas, and so you can watch the first, you can complete part B and D if you want.
Okay.
Or I can meet you back in intervention today, and I can do it with you in intervention, whatever you prefer. Okay. But unfortunately, we only have like a few minutes in between classes, and I have to, we have to transition so fast. Okay.
Yeah.
So in this case, this one here, we've got a hole. So this one's different. We don't have an asymptote. We have a hole, and the hole's at, looks like -1, 4. Okay. Got this hole right here. Open hole. And so the question is what happens when you approach -1 from the left-hand side? This is from the left. So what you do is as you come in and you get closer to the -1 on the left, the function gets higher and higher and higher. It goes up, 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 and you're approaching the hole as you come in from the left. And the y values are going up, so that means they're increasing, and they're getting closer and closer to what y value? What do you see on the graph?
To 4.
That's right. This is a y value. So they're getting closer to 4. So symbolically, we say that as x approaches -1 from the left-hand side, okay, y is approaching 4 because we have a hole and not an asymptote. If we had an asymptote, they go up forever or they go down forever, okay? But this is not the case. This is totally different. We have a hole here, and the hole's at a height of 4. So the y values get bigger and bigger and bigger. They increase, and then they get closer and closer to 4. On the other side, when you're coming in from the left hand or from the right side, all right, you're up here at the top of the function and you're going down. The y values are decreasing, and they're getting closer and closer to 4 because they're decreasing to 4 from the right. So we say that as x approaches -1 from the right-hand side, y approaches 4 as well because you're approaching the hole. There's no asymptote on this one. So it's impossible for the function to go to either infinity or to -infinity. It's approaching a specific value.
I was gonna say, does that happen when there's always a hole? Like it's always gonna go to the number that's missing, like that we have to find?
Yeah, exactly.
Okay.
Yeah, that always happens with a hole. So however high, whatever the y value is in the hole, that's the key number.
Okay.
So either two options here. You can finish up by watching the first part of the class session video on parts B and D, or just try it on your own. Or you can come and see me at intervention today at 1:10, and I can work with you personally some more. So it's totally up to you. I'm
Sounds good.
available if you need me, okay?
Okay.
Awesome. So yeah, big day. So you have a great weekend, or I'll see you on intervention, you decide. And then if not, if I don't see you, have a great weekend and I'll see you next week.
Okay, you too.
All right, see you soon.